Divides is not these little like a half. That doesn't exist. One thing cannot be broken into two pieces. We only think about whole quantities. So since that doesn't even exist, what are we talking about? And so I'm going to use words like A divides B. I'll use words like A is a factor of B. We'll use words like B is a multiple of A. All these words, if I want to use its own symbols, here's where we have a very poor choice of symbols. I want to say A divides B. And so here's how I'm going to write it. A bar B. That is not the division symbol. That is the divides symbol. It's the word divides. Okay, if A divides B in application, A is pirates, B is treasure, right? A pirates try to divide up P or C amount of coins, right? As we go through this. The person on the left is the thing doing the dividing. The thing on the right is the thing that is being broken apart for the sharing. That's what we have to remember. Too often people look at this as a fraction. This is not a fraction. This is the word divides. The thing on the left is trying to share the stuff on the right fairly. When does this happen? This is true when, well, what does it mean to share evenly? That would mean that everybody who showed up somehow gets an integer and we still have the same amount of coins left. So example, can 3 people share 12 coins? Yes. And the answer is because each of those people get 4 coins and we still have the full 12. Can 4 people share a bill of $16? Yes. Why? Because each of those 4 people have to pay $4 and then the bill of 16 would be handled. So we can think of $16 as negatives are owing, right? This is important. I want you to, in your head, think of negatives now as I owe, or better yet, we, because you're one of the 4. We owe this. 4 people owe $16. Well, how do you do that? Let's take $4 from everybody and I can pay the bill. Oh, if it's 12, that's taking, right? Sharing. Now you have positive amount treasure. We're trying to share it amongst ourselves fairly. On the other hand, if not, we use the slash symbol. A does not divide B. So for example, does 3 divide 10? Can 3 people share 10 coins fairly? No. Why? So no, because 3 times nothing equals 10. Nothing. And so what we rather say, so we say 3 does not divide 10. That's what we write. Can 4 people pay a bill of $11? Fairly. No, you can't if we only have $1 objects, right? So that's this idea.
So that's straight up an X, right?
Which one?
Like that one?
No, that's a slash. This is divides. Put a slash through it.
Okay.
It does not divide. This is probably where I should probably use. Be nice if I would use colors on this, right? It cannot. Doesn't divide. Just throw it through. It's like not equal, right? You put equal, put a slash through it, saying that's not true. Okay. Now that we have our operators, plus, minus, times, we already know how those all work, right? On the other hand, what are some properties of divide? If A people show up to share B things, what are some properties that occur on this? So here's the theorem. First thing, if A people can share B objects and A people can share C objects, that would imply that A can divide B plus C. Let's put it this way into coins, right? If A number of pirates can share fairly B coins, and A number of pirates can share C coins, if I took the two piles and put them together, can they still share it fairly? Everybody say yes, right? Would that make sense? Like if I say, ooh, this pile is fine and this pile is fine, if I take two okay piles and put them together, it's still okay. On the other hand, could you prove that? Well, if you're trying to prove something new, you have to go back to something old. What do we all have? We all have college algebra, right? So this is implication, right? How would you prove implication? What are your techniques? Direct, or if you can't handle direct, you would take the contrapositive. And if that seems too hard, you would try contradiction. For example, state the contrapositive of this.
A is not divisible with B plus C.
A cannot divide B plus C implies what? If I negate that thing, I could use De Morgan's law, which would be what? A doesn't divide B, or A doesn't divide C. But I usually don't like nots. I usually like R's. Like this can do, right? It's usually nice to have yes things rather than no things. But I'll try direct. What would contradiction be? We would have the left and not the right, and then show that is always false, right? But direct proof, what do I assume? I assume that A can divide B and A can divide C. And what's my goal? A divides B plus C. Now, I don't like this division symbol, right? What does divide really mean? A divides B means what? A times some int, I'll make it K1, is B, right? And what does A divide C?
A, K2, C.
Right? For some ints K1, K2. They're different integers. I don't know what they are. I was calling K1, K2. All right, what's my goal? What do I want to eventually show?
K1 and K2 is the same.
Not that they're the same. What's my goal? My goal is this. Where are we going? That. What do I want to show? A divides B plus C. Currently, what do I have? B and C. Where am I going? B plus C, right? Do I have B? Yes. Do I have C? Yes. Could I find B plus C? Sure. Since I want to eventually consider what B plus C is, let's go ahead and take that. So B plus C would be what? What is B? A times K1. What is C? A times K2. Hey, do they share an A? Now, time out. What does divide mean? It means that the thing on the left times an int equals the thing on the right, right? That means this A, what were other words? A divides B means A is a factor of B. B is a multiple of A. What do I got? What is B plus C? A times an int. So this B plus C is equal to A times K1 plus K2. So by the definition of divides, A divides B plus C. Why? A is a factor of B plus C. B plus C is a multiple of A. A times an int is B plus C. Is everybody okay with that? So have I proved what I wanted to prove? Yes. I started off with assuming the left, and I've shown the right. How do I prove divisibility things? We have to turn them into algebra. Then we use the algebra to show that we have this. But now that you have this theorem, you can actually skip algebra, right? Now I could just memorize this theorem and say, oh, if I have A divides B and A divides B plus C, I don't have to do any algebra. I can just jump straight to the answer. Second thing that we should know. If A divides B, that implies that actually A divides B times anything for all C that are integers. That's really just the first one a bunch of times, because what is B times C? It's B plus B plus B plus B plus B, right? So just take a bunch of B's. If A divides B, or if I take a bunch of B's, I can shove them all together, it still divides it. So it's actually the first one, used a bunch of times. The third would be if A divides B and B divides C, therefore A divides C. That's normally called transitivity, right? But how would I prove something like this? What would I immediately shift to? Algebra, right? What does A divide B mean? A times a constant is B. What does B divide C means? B times a constant is C. Well, if A times a constant is B and B times a constant is C, that means A times the constant is C. But that means A divides C. I could put all of that together and simply say that, you know what, if A divides B and A divides C, that implies that A divides any linear combination of B and C. So if 3 divides 6 and 3 divides 12, then 3 will divide any combination of 6 and 12. Take a bunch of 6s and subtract a bunch of 12s. Doesn't matter, 3 will divide it. But this was talking only about sharing fairly. That's what divisibility is, right? Can you fairly share it? Now comes the interesting question of you have 7 bags of grain, but you only got 3 people. 3 does not divide 7, right? Why? Because I have a leftover. Everybody gets 2, but I got something left that cannot be shared. So how do I deal with those problems? Well, we'll leave it as leftovers. We'll talk about this idea. So divides itself is talking about what things can divide what things fairly. And now comes the next question of what about, okay, so 3 divides 6, but 3 cannot divide 8. But can I consider this as a problem to work with? Because we will run into it. If I only allow whole quantities, you are going to have 8 bags of grain if 3 people show up. What do I do? How can I consider it? Well, one of the ways that we can consider it is to rather do this thing. The 8 bags of grain can be thought of as each of the 3 people get 2, but then I have 2 left over. And I might have things like 3 does not divide 7. Well, I could consider this rather as, well, the 7 is everybody gets 2, but I have 1 left over. But on the other hand, 3 divides 6. Well, that's okay. 6 is 3 times 2, and I have nothing left over. So what I could do is think of the sharing. We could do the sharing part, how much is shared evenly, but then I could ask for leftovers. So now I can do all of the problems. And I say divisibility is now no leftovers. Non-divisibility is leftovers. Now, if you're smart and you share, what do you notice about the leftovers? For example, for 8, right? 8 was 3 times 2 with 2 leftovers. What happens at 9?
You can go back to
I can share it evenly, and how many leftovers do you have? 0. What about 10?
go back to having 1 left.
It's 3 times 3 plus 1. I have a leftover. What about 11? 3 times 3 plus 2. What about 12?
Back to 0.
Back to 0. What do you notice about your leftovers?
So you have 3.
You have 0, 1, or 2. What would happen if you had 3 leftovers? You would say, well, of course, I can share that. Everybody gets one more bag, and we're back to 0. So it looks like if we actually do it right, and what people do, leftovers are always 0, 1, or 2. Because if it's 3, you should have shared it.